Okay, this is for section 2.7, and it's called Parent Functions and Transformations. And I will tell you that this ties in closely with what we're doing right now in Trig. Okay, so any of you that go on, you would have already had some of the background in here. So that's to your advantage if you go on into Trig. Okay, it's Parent Functions and Transformations. Okay, first, a couple of definitions. They talk about a family of graphs. Okay, and you've already seen some of them where you see several absolute values that all look kind of like a V shape. Okay, so it's where a group of graphs that display one or more similar characteristics. So like all the absolute value graphs would be considered like a family of graphs. And the original y equals the absolute value of x would be like, that is called the parent graph. So there's basically a graph to start with, and it is the simplest of graphs in the family. Okay, the author also calls that a parent function. If it is a function, has to pass the vertical line test. Okay, we are going to look at basically 4 of those parent functions. Okay, and the first one is called the constant function, and you have already worked with it even today. The constant function. A constant is like a number. Okay, so the constant function is like y equals a number, where a represents a number. So like y equals, if I said y equals 3, okay, in the graph, if I said y equals 3, it could be a horizontal line. Okay, so that's the constant function. Any y equals a number is going to be a horizontal line. Another parent graph is the identity function. Okay, it's called the identity function. Okay, and the main graph is y equals x. Okay, the identity is y equals x. And y equals a number. If you did, if in y equals mx plus b, it's going to go through 0, and the slope is 1. So you're going to go to the right one, up 1, right 1, up 1, right 1, up 1. So it's going to go right through at 45 degrees. Okay, and that's the identity function, or parent graph for the identity function. Okay, and you've already really seen the absolute value, function. And these are all functions that all pass the vertical line test. And the absolute value function, you'll figure out, is going to look like a V-shaped graph, kind of like that. The equation is just going to be like y equals the absolute value of x. That's the parent graph. Y equals the absolute value of x. Okay, and the fourth one is the quadratic function. Okay, the quadratic function. Okay, and a quadratic means its highest exponent is going to be an x squared. So the parent graph is like y equals x squared. And any quadratic, you can make a table of ordered pairs for that. And if you graph that quadratic function, it's always going to end up to be a curve that looks like this. It's called a parabola. We'll get into that more when we do the conic sections. The y equals x squared is the quadratic function. Okay, then the author also talks about translations in this section. Translations, and I always think of them, it's like a slide on your graph. You're going to slide your whole graph, okay? The whole graph moves, the graph moves up. I'm using an up arrow, up, down, left, and right. Translations are slides, okay? Now, to help get you ready for trig, I'm actually going to use what we do in trig. If we do a slide up or down, if you do a slide up or down, we're sliding, and we're going to call that a vertical shift. VS stands for a vertical shift. We're sliding the whole graph up or down. And I'm just going to use, and you should just use VS. So you're going to take, and I'll show you on the directions. We'll go through some examples. If you slide the graph left or right, okay, that is called a phase shift, left or right. So translations are vertical shifts and phase shifts, sliding it left and right. And I'll go through examples. They're also called transformations, okay? You're taking the graph and transforming it into something else, okay? And I'm basically going to do these with one parent graph. We're going to do the absolute value function, okay? Okay, so these will all be transformations, not just translations. There are also going to be some other transformations of the absolute value, the absolute value function. Okay, and we're going to do them on the calculator. Okay, you can do them by hand, but we're going to do them on the calculator. So what I need you to do is to graph on the calculator y equals the absolute value of x. Okay, so we go into the y sub 1, and for those with the older calculators, we're going to use the math key, and then right arrow over to number. And it should be the first one. Now, those of you on the new ones will actually have absolute value symbols around it. Okay. So, on your calculator, okay, and y sub 1. And you want to make sure you don't have any plots on. Those should be all light. If you have any plots on, do second function y equals and turn the plots off. So we need to go to the math key, right arrow over to number, absolute value of x. Okay, and then I'm gonna use let's just use the zoom standard. Zoom. Let's do zoom 6. Zoom standard. Okay, and you get the same. It's because you have more pixels going across the screen. So you can do, yesterday we did zoom squared and squared it up, but I'm not going to mess with that today. So for right now, this is our parent graph. Should look something like that. Just as, all I need is a sketch of it in your notes. Okay. Now, if we do a transformation, as an example, I want you to put a +2 on the outside of the absolute value. So go down to y sub 2. You want to put this in y sub 2. Okay, and put the math key, right arrow over to number, absolute value of x, close that off, and then put +2 and graph it. Okay, what you should see is that that was a transformation up 2. So, okay, on this we want to do that. That is a vertical shift up 2. Okay, it has to be on the outside, up 2. Okay, let's do another one. Did everybody get that? Okay. Okay, so then let's Let's do another one. Let's do y equals the absolute value of x. Close that off, and then, so we're just going to type over, go down to y sub 2, change that plus sign to a minus. I have to make sure it's a minus sign, not a negative sign. Minus 3. Okay, so here's the original. So the effect of that, move the whole graph down 3. Okay, so it did a vertical shift down 3. So if the minus sign is on the outside, it's going to do a vertical shift down 3. Okay, that's all you need to show on that one. Okay? Good? Okay. Okay, the next one, we're going to change that in y sub 2. We're going to change it to the absolute value of x. Now, instead of putting the 2 on the outside, I'm going to put the 2 on the inside. The plus 2, I want you to put it on the inside. Okay, so go down to y sub 2, change that to plus 2, and then close the parentheses. On my calculator, it looks like this, the old version. Your new ones are going to just look like the way I wrote it. Okay? Okay. I want the original parent graph in y1. Okay, and then graph it. So if we put that 2 on the inside, yeah, that plus sign, to me it goes exactly opposite of the way you think it should go. A plus sign normally we would think would go to the right, so it goes to the left. So you may want to highlight that plus sign. If that's a plus sign and it's the 2 is on the inside, okay, now this is not a vertical shift. This is a horizontal shift, and in trig we call it a phase shift. So this is a phase shift when you slide the graph left or right. It's also called a translation. So if you check it in the book, the author may say translation. I'm going to use this. So it's a phase shift to the left, 2. Okay? Minus sign is going to go to the right. So on this one, let's do this one first. So this one, it took the whole graph and slid it to the left 2. Okay, so now let's go through like if we did, let's change the number there. Let's change it to minus 3. Okay, and let's graph it. Okay, so put that in. Change that y sub 2, go absolute value of x minus 3. And then graph it. There's your parent graph. Okay, so it actually did a phase shift. Which way? To the right, 3. Notice on these, it's not negative 3. The direction is the arrow, okay, and then it's always absolute value. This number is always a positive value, okay? So this one moved it to the right, 3. Okay. So you have to keep track of, is the number on the outside, okay, is the number on the outside. If that's numbers on the outside, it's a vertical shift. If the number's on the inside, it's a phase shift left or right. Okay? What's that? We're still going. Okay? Okay, the next one is a reflection. A reflection is where you take the whole graph and reflect it about a line. A reflection reflects the graph about a line. And the line is called the line of reflection. Okay? Okay, so for number, I think it's number 6, is that right? Number 6, y equals, this time we're going to take and put a negative sign in front of our parent function. So in y sub 2, okay, do negative, make sure it's a negative sign, not a minus sign. Negative, and then the absolute value math key right over the number, absolute value of x. So what that does is it's taken every y value times a negative 1. So here's the original. Okay, it reflected that graph. Okay, so let's graph it first. Okay, this one, it's actually going to take that graph and put it down here. It's a reflection. It folds that graph over the x-axis. Okay, so this one, it is a reflection about the x-axis. You put that negative sign in front, it reflects the whole graph about the x-axis. Okay, on number 7, y equals the absolute value. This time we're going to put the negative in the inside. Okay, so go back and change. Take the negative on the outside, delete that. Remember, you have a delete insert key up here, right here. Okay, and then insert, do second function insert, and insert the negative sign. Make sure it's the negative sign, not the minus sign. What's that? And it's graphing it right over. So what is actually happening is it's taking that graph, it's taking this graph and folding this graph over the y-axis. So wouldn't this lie right on top of this?
Yeah.
Yep. So you're not going to see a change. It's the same graph. If you have the colored calculators, like, you can see it because one's red and one's blue, something like that. So on this one, the actual final answer does not look anything different than the parent graph. But it's actually, this line is actually your axis of symmetry. And it folds this. Yeah. So, yep. So this is a reflection across the y-axis. So the y-axis would be your line of reflection. It's a reflection about the y-axis. Okay. Okay, now they're going to do what they call dilations. Okay. A dilation. A dilation is a shrink or enlarge the graph proportionally. We're going to do what they call a vertical stretch or shrink proportionally. A vertical stretch or shrink and a horizontal stretch or shrink. Okay? And it's best to do it by example. So number 8 is take our parent graph and put a number larger than 1 on the outside. Okay? So in y sub 2, we need to insert a 5, delete that negative sign, so you get 5 absolute value of x. So graph the original. Okay? Now, what that did, look up here a minute, what that did is that took that vertical graph, that stretch, and did a vertical stretch. If it stretches it this way, doesn't it take that V and make it closer together? Yep. So this one is a vertical stretch. I would go with stretch. Vertical stretch by a factor of 5. So it's going to take the original graph and it's going to make it, it's going to stretch it vertically. Okay? Okay, now, that's because this is a number bigger than 1. Okay, now let's put in a fraction. So all I'm going to do is make it 0.5, so that means the fraction's 1/2. So let's insert a decimal point. On y sub 2, insert a decimal point in front of that. Okay, so here's the original. Not yet. Then you start doing other things before. Then you're doing reflections and dilation at the same time. Okay, so on this one, look up here for a minute. If it's a fraction, it took and did a vertical shrink. it squishes that graph vertically down together, which flattens out the V. Okay, so on this one, it's going to make that V come down something like that. Okay, that is a vertical shrink. Squishes it together. Okay, by a factor of, on this one I did 1/2, by a factor of 1/2. Okay. Okay, we're getting number 10. Now we're going to do the horizontal. Okay. Very similar to what we did up above. Now instead of putting the number on the outside, now we're going to put the number on the inside. So let's do the 5 on the inside. Okay. So change your y sub 2 to be absolute value of 5x. Graph it. Does it look very similar? Okay. Yeah, and look up here. Instead of doing a vertical stretch up and down, now it's doing a horizontal shrink. Okay. So this one, if the 5's on the inside, it's still going to look like this, but now this is considered a horizontal shrink. You squish it together. This is a horizontal shrink by a factor of 5. Okay, and last one. Okay, if we have y equals, let's put a decimal point in front of that, so make it 0.5x on the inside. Okay, so insert a decimal in front of the point, in front of the 5. And that takes, it looks like the other one, but it's basically doing that same graph and stretching it out this way. Yep, so this one's a horizontal stretch. So it flattens it out. Okay, so this one is a horizontal stretch by a factor of 1/2. Okay, so we've taken one parent graph and gone through all the different transformations. Okay, if you go back up and look, we did transformations. We did vertical shifts up and down. We did, if you put the number on the inside with a plus or minus sign, that one is the one that if it's a plus sign it goes to the left, if it's a minus sign it goes to the right. We multiplied by negative signs, and those are reflections. Then we multiplied by numbers. We did the vertical stretch and shrink and the horizontal stretch and shrink. Okay? Okay, I'll give you time to work.